In this video, I'm going to go over problems 88, 89, and 93. Your homework's 94, 95, 98, and 99. This lesson's on tangent lines. So it's a little bit different than tangent, the trig function, opposite over adjacent. A tangent line when we're talking about a circle. So, for 88, it says, consider all the ways a circle and a line can intersect. Can you visualize a line and a circle that intersect at exactly one point? What about a line that intersects a circle twice? Draw a diagram for each of these situations if possible. If it's not possible, explain why not. So 10-80, or part A here, draw a line and a circle that don't intersect. Should be pretty straightforward. Circle a line that don't intersect. Part B is a line and a circle that intersect at exactly one point. So my circle, to get it to intersect at exactly one point, you can't do this. That doesn't work because this isn't a line. A line goes on forever in both directions, so if this goes forever in both directions, it doesn't work there. So to get a line and a circle to intersect it exactly once, it just kind of needs to barely touch the edge right there. This is what we call a tangent line. It only intersects the circle at one point. Part C is a line that intersects a circle at 2 points. This is called a secant line. We're not really going to study secant lines. I think you know the word, you've seen it. So it's just a line that intersects a circle twice. And then part D, you want a line and a circle that intersect 3 times. This is not possible because a line has to be straight. So that was just to kind of introduce what a tangent line is. It intersects a circle at exactly one point. So on problem 89, if you have tracing paper, that's awesome. I don't. But they give us this picture like this. So this is point P here. This is line L. And the center of my circle is C. So what they want you to do is fold the tracing paper, if you trace this, so that it passes through points C and P. So if I trace this and folded it, this would be my crease. And it would look like that. And it says, what do you notice about the diameter in relationship to the tangent line? So hopefully you can still see it in this picture, even though it's not drawn perfectly to scale, is that this makes a right angle. So one important thing to kind of know to learn about tangent lines is tangent lines are perpendicular to the radius or diameter. The radius would just go from C to P at the point of tangency. The point of tangency, that's just where the circle and the tangent line intersect. So, oops, let me get that all on the screen. So the point of tangency is here. So this just means tangent lines are perpendicular, means they make a right angle, to the radius at the point of tangency. Anytime tangent line, if you connect the point of tangency to the center, you have a right triangle or right angle. So for problem 93, we're just going to apply some of this stuff. And it's a good mix of review here. So let me draw the picture for A, and then it gives us a lot of things. Hopefully you're following along in your book. Okay, so that's what the picture looks like, and it tells us a few things. PQ is tangent to circle C at point P. So if this is tangent, that tells us right away, makes a right triangle. Then it tells us PQ is 5, and CQ, this whole thing, is 6. We want to know CP and the measure of angle C. Well, to find CP, we do the Pythagorean theorem. I'm just going to call it x. X squared plus 5 squared equals 6 squared. 6 would be the hypotenuse here. So x squared plus 25 equals 36. Subtract 25 on both sides. X squared equals 11, so x equals the square root of 11. So CP is equal to the square root of 11, and if you want to turn that into a decimal answer, that's about 3.32. And then if we want to find the measure of angle C, we're looking for this guy up here. I'm going to use, this side is the opposite and this side is the hypotenuse. So we could use the adjacent since we already found it, but it's rounded or it's a square root answer, so I'm going to use the other ones. So opposite and hypotenuse, SOHCAHTOA. Hopefully you remember that. That lets us know we're using sine here. So sine of C is equal to 5 over 6. Remember here you do inverse on both sides. So sine inverse of sine of C equals sine inverse of 5 over 6. By doing that, these cancel out. So C is equal to sine inverse of 5 over 6. Have to have your calculators, make sure it's in degrees, which is about 56.4 degrees. All right, part B. This circle has a few different things going on. So here's point G, this is H, this is O, this guy is R, and up here we have D. So in the book it tells us in circle H, that means H is the center, DR equals 40 degrees. And arc, the measure of arc GOR equals 210. So GOR to here is 210. We want to find the measure of arc GD. We also need to find the measure of arc OR and the measure of angle RGO. So GD, that's this guy up here. As a reminder, all the way around the circle, we should know has a sum of 360 degrees. So from G to R, passing through O is 210. Then we go another 40. Then whatever is missing is going to be GD. So 210 plus 40 is 250. So it's 250 degrees from G all the way to D, the major arc, the big one. So then we do 360 minus 250 to get 110. So the measure of arc GD is 110 here. Alright, next the measure of arc OR. So OR is just this little guy. We know GOR. So arc GOR is 210. But because they told us H was the center, that lets you know from G to O is 180. And so 210 minus 180 gives you 30 degrees. And then the last part here, the measure of angle RGO. So we got that this guy is 30 degrees. We want this angle right here. RGO uses the endpoints RO. So you just cut 30 in half. The inscribed angle is half of the intercepted arc, so that's going to be 15. It's half of 30 there. And lastly here, part C, we have, looks kind of like this, point E, A, B, C. It tells you AC is a diameter. The area here is 289 pi units squared. AB is 16, so this is 16. And we want to know what BC is and the measure of arc BC. Okay, so if they give us the area, we know the equation is the area for a circle is pi r squared. So by substitution, 289 pi equals pi r squared. Pi's go away, so 289 equals r squared, which tells you r is 17. So you just take the square root of 289. So square root both sides here. So r is 17, the radius. So if this is the diameter, that's 17 and 17, or the whole thing would be 34. So if I want to find BC, I'm just going to call it x again for simplicity. I have x squared plus 16 squared equals 34 squared. So you do Pythagorean theorem here to find x, which is going to be BC. So 16 squared is 256. 34 squared is 1156. So if I subtract 256 from both sides, I get x squared is 900, or x equals 30 when I square root both sides there. So BC is 30. And finally, they want the measure of arc BC. This has more trig, just tying kind of everything together here. So the measure of arc BC, if I can find angle A, I would double it to get BC, because that's the arc and A is the inscribed angle. So if I want to find angle A, I can use any sides I want. I know this is a whole number. So this is opposite and this is adjacent. Again, A is my theta that I'm looking for. So going back to SOHCAHTOA, this is going to be tangent of theta is 30 over 16. So theta equals tangent inverse of 30 over 16. Which gives us approximately 61.9 degrees. So again, that's 61.9. That's angle A inside of the triangle. And remember, I was saying we want to find arc BC, so if you think about kind of this picture, I'm running out of space here. We're looking for this arc BC here, and this angle is 61.9 degrees. So to get this arc, we just double 61.9, which is going to give us 123.8 degrees, approximately.